Today, I want to discuss a fundamental breakdown in communication between atmospheric scientists and physicists concerning greenhouse warming theory and some continuing problems in understanding how air is heated. We are still facing a basic problem concerning the physics of heat. Is heat a substance that flows or a spectrum that glows? Chemists claim that heat is a substance that flows. After all, chemists spend their lives measuring amounts of different substances. In 1667, Becher postulated the existence of a fire-like element called phlogiston that was presumed to be the substance of heat liberated from matter during burning. In 1783, Lavoisier, the father of modern chemistry, proposed that the substance of heat was caloric, a self-repellent subtle fluid. A substance is measured in amounts that can be added together. Physicists, on the other hand, who spend their lives measuring motion, claim heat as a spectrum of frequencies. In 1620, Bacon wrote, "The very essence of heat, or the substantial self of heat, is motion of small particles within matter, and nothing else." In 1681, Hooke wrote, "Now heat is nothing but the internal motion of the particles of a body, and the hotter a body is, the more violently are the particles moved." In 1850, Thomson proposed thermal energy as kinetic energy of oscillation, an idea central to our current thinking. A spectrum is a distribution of frequencies of oscillation. What is critically important is that it makes no physical sense to add frequencies of oscillation together. They coexist. In 1859, John Tyndall showed that greenhouse gases absorb infrared radiation emitted by Earth. Tyndall measured how much infrared radiation from Earth is absorbed by different greenhouse gases. He concluded that water vapor was by far the strongest absorber. The more atoms per molecule, the greater the absorption. It has been assumed to this day that if greenhouse gases absorb infrared radiation, the air containing the gases must get warmer. In 1896, Arrhenius was the first scientist to quantify greenhouse warming theory. Arrhenius was a physical chemist who spent several years in some of the best chemical laboratories in Europe, but still concluded, in order to get an idea of how strongly the radiation of the Earth is absorbed by quantities of water vapor or carbonic acid, in proportions in which these gases are present in our atmosphere, one should, strictly speaking, arrange experiments on the absorption of heat from a body at 15 degrees by means of appropriate quantities of both gases. But such experiments have not been made yet, and as they would require very expensive apparatus beyond that at my disposal, I have not been in a position to execute them. So he made many assumptions and did a lot of arithmetic. I disagree with his conclusion. I did a relevant experiment for only the cost of a dual-channel digital thermometer and found no warming effect. A few experiments have been reported on the internet, but they use heat sources that are way too hot. To this day, no one has shown that greenhouse gases absorbing terrestrial infrared radiation can warm air. If Arrhenius had worked on greenhouse gases in the laboratory, he would have proven the theory wrong. Arrhenius was an excellent scientist, one of the founders of physical chemistry, who earned the Nobel Prize in Chemistry in 1903. But he was a fish out of water when studying the physics of greenhouse gases. He just wanted to find a way to show warming of 5 degrees out of the last ice age could be explained by a doubling of the concentration of carbon dioxide as suggested at meetings of the Stockholm Physics Society. In 1900, Angstrom showed less than 16% of terrestrial radiation was absorbed by carbon dioxide. Angstrom was a radiation physicist and friend of Arrhenius, who concluded from two simple experiments as follows. It's clear, first, that no more than about 16% of Earth's radiation can be absorbed by atmospheric carbon dioxide, and secondly, that the total absorption is very little dependent on the changes in atmospheric carbon dioxide content as long as it is not smaller than 2/10 of the existing value. It is only the resonant frequencies of the bonds holding a molecule together that are absorbed into these bonds, as shown by the red spectral lines of absorption. This has no direct effect on air temperature. Physicists lost interest in greenhouse warming theory and soon became preoccupied with quantum mechanics and particle physics. In 1900, Planck devised a law showing the relationship between temperature and oscillations of all the bonds holding matter together. Planck's empirical law, based on extensive observations, calculates the amplitudes of oscillation, which we perceive as intensity of radiation, that must exist at each and every frequency of oscillation for a body of matter to possess a given temperature. Temperature of solid matter is the result of oscillation of all the bonds that hold solid matter together. Thermal radiation is clearly a spectrum of frequencies of oscillation that glow. We observe this in a campfire that turns from red hot to white hot. Note that the temperature is a value on a scale such as Celsius and Fahrenheit. There is no such physical thing as an amount of temperature. Heat is the flow of temperature, so there is no such physical thing as an amount of heat. In 1938, Callendar, a steam engineer, resuscitated greenhouse theory from the trash heap of history. Callendar dismissed Angstrom with this one phrase: Angstrom could not obtain any measurable effect, as would be expected with the apparatus that he used. The fact is, to this day, no one has ever obtained any measurable effect on air temperature by greenhouse gases absorbing terrestrial infrared radiation. Then in 1965, it was the geochemists who brought greenhouse warming to the national attention. No one trained in physics since Angstrom has seriously questioned the physics of global warming or the physics of heat until I got involved around 2010. None of the tens of thousands of peer-reviewed papers documenting the global scientific consensus about greenhouse warming theory question the physics of global warming, although it is the physics that determines how and by how much global warming occurs. Meanwhile, physicists began to understand that matter consists of atoms and molecules. They discovered electrons in 1897, the nucleus of the atom in 1908, protons in 1917, and neutrons in 1920. Current but mistaken thinking about amounts of heat have worked adequately in engineering and thermodynamics, provided the differences in temperature are small. But they break down catastrophically for Sun at 5,500 degrees Celsius and Earth at only 15 degrees Celsius. It is now quite clear that temperature of solid matter is the result of simultaneous oscillation of all the bonds holding matter together. Thermal radiation is an extremely broad spectrum of frequencies of oscillation, whose amplitudes of oscillation are a function of the temperature of the body. Thermal radiation is the simultaneous transfer of amplitude of oscillation via resonance between each of these tiny oscillators on the surface of the hotter body and similar oscillators at the same frequency on the surface of the cooler body. Unfortunately, I do not have time today to explain the details of resonance. There are only 3 ways air is warmed every day. First, the troposphere is heated from below by Earth's sun-warmed surface. The tropopause is the boundary between the troposphere heated from below and the stratosphere heated from above. Second, the stratosphere and mesosphere are heated from above when solar ultraviolet radiation dissociates primarily oxygen and ozone, breaking a molecular bond, causing the molecular pieces to fly apart at high velocity, converting kinetic energy of bond oscillation completely and efficiently into kinetic energy of linear motion, which is proportional to gas temperature. Third, the ionosphere is heated from above when solar high energy radiation ionizes primarily nitrogen, oxygen, and nitric oxide, causing the electron and the ion to fly apart at high velocity, converting kinetic energy of oscillation of the electron bond completely and efficiently into kinetic energy of linear motion, which is proportional to gas temperature. Infrared radiation does not have enough energy to dissociate anything. Greenhouse warming theory assumes, first, heat is defined as a flux, an amount of thermal energy flowing per second through an area. Second, heat is quantified in amounts of watts per square meter. Third, heat from different sources are additive. Current warming is supposed to be caused by the net absorbed of 0.9 watts per square meter, shown in the red ellipse. Fourth, the greater the net amount of heat absorbed, the hotter the body becomes. Fifth, Earth gets hotter when the Earth atmosphere system loses a lesser amount of heat to space than it absorbs from sun. None of these assumptions turn out to be correct. To understand why, we need to look at the differences between extensive and intensive physical properties first pointed out by Tolman in 1917. Extensive physical properties describe external measurable properties or motion typically of a macroscopic body of matter. Examples: length, area, volume, mass, size, weight, quantity, amount. Extensive physical properties measure how much of an object exists and changes when the size, extent, amount, or mass of a sample changes. A macroscopic quantity or amount of something. Extensive physical properties are additive, meaning they can be added together or integrated as a function of. Intensive physical properties, on the other hand, result from the physical properties or relative motions of atoms and molecules distributed evenly throughout a body of matter. Examples include temperature, heat, density, color, hardness. Intensive physical properties are bulk properties that do not change when size, extent, amount, or mass of a sample changes. A submicroscopic distribution of properties that coexist. Intensive physical properties cannot be added together in any physically meaningful way. Greenhouse warming theory assumes heat is extensive and additive, but heat clearly is intensive and therefore not additive. That means that all the calculations done by computer models of climate are mistaken. In conclusion, heat simply does not flow in the ways assumed by greenhouse warming theory. Heat is a spectrum of values that is not additive. The rate of heat transfer is determined by the difference in temperature. Greenhouse warming theory is not only mistaken, it is not even physically possible. How long will it be before climate scientists take their heads out of the sands of consensus, evaluate the evidence, and update their recommendations to policy leaders? Greenhouse warming theory is rapidly becoming the most expensive mistake ever made in the history of science, economically, environmentally, and politically. Temperatures are expected to decrease over future decades as the ozone layer recovers. We can burn fossil fuels safely, provided we minimize pollution. Thank you.